Hey you guys, it is me, Miss Norris. This week's lesson, this week's lesson is focusing on linear functions as a whole. So basically you have two learning targets. We are basically, the goal for this lesson is, can I create a linear equation y equals mx plus b from different representations? And can I interpret what those equations means in real words? So let's go ahead and get into it. For your do now, I want you to be able to find a rate of change from the table. We've been focused on rate of change, so in this lesson, we're not going to be primarily looking at how to find a rate of change, but I do want to go ahead and get that mind working. So looking at the table, can you find a rate of change between the two, between the chart? So again, remember, rate of change is the rate of change that's found between the equation y, the difference of y over the difference of x, where the triangle right here means the differences. So if I was to look at it, I'm going to see, well, how do I get from 0 to 2, 2 to 4, and 4 to 6? I'm going to add 2 to each one. How do I get from 6 to 12, 12 to 18, and 18 to 24? I added 6. So going back to my equation, I'm going to find the differences of the y side, which was plus 6, and put that over the differences of x, which was 2, and divide where I get 6 over 2, which gives me 3. So before we can really get into like how to find the equation, I want to make sure that we know what the parts of the equation is. So again, the equation is y equals mx plus b, where y is all these different words. It's your output, it's your answer, it's your dependent variable. Your m is your slope, your rate of change, the proportional relationship, or the constant proportionality. Your x is the input, your independent variable is what's changing, how many per something, that's that change. And your b is your y-intercept and initial value, which is what we're going to focus on today. So when I'm trying to figure out how do I compose an actual linear equation, remember what I'm not doing is changing your variables, because they're going to change on their own. It's going to change throughout the situation, whatever the situation is. So I don't want you necessarily to put an actual hard, concrete number into these positions. They need to say a y and an x. However, what we would be doing is figuring out what the b and the m is in the situation. These are fixed numbers. They're not going to change throughout the situation. So I need to find these two numbers. So what I want to do is first, I want to go ahead and visit Desmos.com. If you haven't used that in your class, it's a really cool website that basically just shows us, if I give you an equation, what would the line look like? And so you should be able to click here, but if not, again, Desmos.com/calculator. It comes up. You don't need to log in for anything like that. But I want to go through the website, and I actually just want to see, like I said, it's really easy in case you didn't do it, but Desmos calculator, and I want to see how does everything in this equation actually affect me. So with the first one, I'm going to put the first equation. I want to see the differences between them. So I'm going to put y equals 3x and press enter. There's my line. And as you can see, y equals 3x with a proportional relationship. It does not have a y-intercept, so it went through the origin, right? So then I'm going to do another line. And the next line was y equals, I'm going to keep the slope the same, because again, we're not really focusing so much on the slope as much as the b. So I'm going to put 3x plus 4. And I want to see the differences. So look and see what happened to your actual line. And I'm going to do one more line where I'm going to do y equals 3x minus 4. And then guess what? You're seeing that throughout all the lines I gave you, there are some similarities and there are some differences. So I want you to take a minute and think, what are the similarities and what are the differences? How did these lines, 3 lines, change? And what changed in the equation to make them change in the graph? So then let's think of our differences. So basically in our differences, let's see. With the 3x, we already said that was a proportional relationship. It went through the origin. When the y equals 3x plus 4, it's no longer proportional. So anytime you have a y-intercept, it's no longer proportional. So that means you cannot simply divide the x into the y to get the rate of change. We now have to do like we did with the warm-up and find the differences all the way down. However, with my plus 4, I see that my line crossed the y-axis 4 points above the origin. So you'll see that it was higher than the original red line. And then again, for negative 4, we're going to see that it was actually crossed 4 points below the origin. So you can see that it started out a little bit lower. So again, coming from that, your B controls where your actual line crosses your y-intercept, and that y-intercept is always going to dictate what you started off with. So if I started off with a positive number, then it's going to be above the origin. Say I started off in the hole. Maybe I started off owing someone money. I'm going to be below that 0, mark. So let's see how we find the y-intercept through, so I'm looking for the B, through origins. Equations. So looking at the equations, y equals 3x minus 5 and y equals negative 1/2 x plus 9, I'm really looking for what is in this spot. Now, however, even if I say it doesn't look like this equation automatically, I'm looking for the number that is a constant. That means what number was given to me in the equation that did not have a variable attached to it. So that would be negative 5 and positive 9. That's what my y-intercept or my initial value will be. Negative 5 and 9. Now let's say that I'm giving a verbal descriptor. Remember, a verbal descriptor is like a word problem. It didn't really give me an equation. I had to pull my numbers and set it up myself. So the first one says a painter charges $15 per hour to paint a room plus $75 a paint. So my per unit is my M. Remember, that's what's changing per one independent variable. So that makes 15 my M. But plus the 75, no matter how many rooms you paint in that house, you have to give those people $75. So that's what I'm starting off with. So that's always going to be my B. Whatever I start off with, whatever I have to give them before they can start working, whatever I require before I do anything is my B. The same thing as if a plant is 13 centimeters tall and grows 2 centimeters a week. It's already 13 before I started measuring it. So that's how it started off. So then therefore, yes, 75 and 13 would be the B. And again, all we're doing is looking for the B to plug it into an equation. Now, finding your M through a table. We're going to come out of here and we're going to go to the camera so we can see what we're really working with. So, we're looking at, and like I said, as we get into this moment, we are not using just, oh, I can divide my y into my x. We have grown past that. That was only for proportional relationships. So looking at this, if I have a table and it gave me a 0 in the x, this is automatically my B. My B is literally 6. It gave it to me. If they gave you 0, you have nothing to figure out. It was given to you. Now say they do not give you 0, such as this one. This one told me 2, 3, 4 was 44, 52, 50, and 61, right? So I know though that, okay, if I came from here to here, it was 1. So to go here to here, I'm still doing that. And I'll even go this way to keep our pattern going. So from 4 to 1, I minus 1. From 4 to 3, I minus 1. From 3 to 2, I minus 1. From 2 to 1, I minus 1. And from 1 to 0, I minus 1. Okay? And remember, I want my 0 to be matched up. So let's see, how did I get here? To get from 61 to 52, I'm going to have 61 minus 52, 50. So clearly, if I'm going down numbers, I minus 850. So I'm going to keep that going. So let's start again. 61 minus 850 gave me 5250 minus 850 gave me 44 minus 850 gave me 3550 minus 850 gave me 27. So therefore, my y-intercept is 27. Okay? And then, say for any instance that say that I started at 20 and I only counted by 1. I do not expect you to count up each time by 1 from 20. Or even something big like a 68. So, let's look at this same exact graph and see what if it didn't give me. And actually, we'll look at this one. Say it didn't give me that. Say it started with 4, 6, 18, and 24. What you would do is see what's my difference between
4, and 6, which is 2. 2 plus 4 gives me 6. And then I will look for what's the difference between 18 and 24, which is 6. I will then do my 6 over 2, which gave me 3. So now that I found my M, correct? So first step, find M. And then my second step would be plug in what I know into the equation. So plug in what I know. So if I'm trying to find B, I now gotta use things that I know to find that missing part of my equation. So y equals mx plus b. I can use 18 for a y equals my m, which is 3, times the correlating x, which was 4. And I don't know b, so I'm going to leave it that way. And now I'm really going to solve for b. Solve for b. So again, all the operations, I'm going to times 3 times 4, that gives me 12. Drop down everything. My next step will be to isolate b. So that's minus 12 on both sides. 12 minus 12 is 0. Bring down my b. Bring down 18 minus 12, which is 6. So therefore, b equals 6. And as we see, we use this same chart from the first one, so let's see if all of them match. Okay? So, we're going to go back into our PowerPoint. And so basically it does. The initial value is 6 whenever y is whatever y value is when x is 0, or completing my chart. So again, defining from a graph is literally identification. If I have a graph, I'm going to find my origin, which is where my two axes cross. That's usually where the arrows are. And this is my origin. I'm going to count my units up until I find the line, right? So I went up 1 unit. There's my line. For this one, here's my origin right here where my axes cross. 2 units up. So, again, my intercept would be 1, so 1 unit for 1 ounces, or 2, because I went up 2 from the origin. So then again, our first learning target is, can I create the actual linear function? So what if after I've done all my work, right? I've done all my work, I'm sorry, I was typoing it. But I've done all my work, and I found my M, I found my B, and like in my class, I like to actually make lists of things, because I want to make sure that I have everything I need, all my ingredients to make whatever I'm trying to make. So right now we're trying to make a linear equation, y equals mx plus b. So all I'm going to do is plug in my rate of change for what I found for m, and plug in whatever I found for b into my initial value spot. So my rate of change was negative 4 over 3, and my initial value was 2. I'm really just plugging it into y equals negative 3 over 4x minus 2. Plus 2. And that's all I need. So when we're asking for a linear equation, or what's the equation that represents this situation, we want y equals negative 4x plus 2, or whatever you found for your rate of change. So again, let's go back into this. So if I'm interpreting my equation, I'm really only telling you how my x and y were affected by using the meanings of the b and the m. So again, the meaning of the m is how much the independent variable is changing. Either it's increasing or decreasing every unit. My B is where did I start off with? So I want you to use those sentence starters as how you interpret an equation. So such as if I was given the equation y equals 5x plus 6, I can interpret that or create a story for anything, such as my rate that I'm changing is 5 and I started off with 6. So one example could be I started off with 6 cookies and I made 5 every batch, right? My increase or my cookies were my independent, and that's what I'm changing every time. There's 6 students in my class, and 5 more enter every minute. I started off with 6, and the change is plus 5 every time. Or I have $6 in my pocket, and I make $5 every hour. Every hour, I'm getting more and more $5, $5. Your 5 is what is changing, and your 6 is what is stayed the same what I started off with. So I hope that this video was super helpful. Again, feel free to reach out to your teachers, email us, post on your team. Post in your assignments. If you need help, call us. Use your s'mores link to make sure you have our correct Google Voice numbers. As always, we love and miss y'all so much. Let us know any assistance that we can do for you. We're going to get through this. All right.